Hi, everybody. I'm Corey the New. Thanks for having me today. Really excited to be here. My talk is about So You Think You Know Go. So this talk is really about things that I thought I knew about Go, but actually did not. Now, some of these things I did know that I'm going to cover today, but I think we're going to find that some of these things over the years I actually learned while I was doing training. So once upon a time, I thought it would be a great idea to go out and be a Go trainer. I was really passionate about Go. I really liked it. And I wanted to teach more people about Go. So the reality is that you never know enough about Go to actually be a trainer. And so you just have to go do it. Now, clearly you have to know a little bit about Go. I'm not saying that run out there and if you've never done Go, start training. I'm not saying that. But I think based on my experience and having done this for a while, I think the reality is that to be a trainer, you just have to go out there and do it. And it's going to be a little rough around the edges when you start, and things are just going to keep getting better as you go. So a little bit about me. Now, normally I really don't tell my story, but for this talk, it's kind of important to have some context. So I've been doing Go daily in production since it was publicly released in 2012. So that's a little while ago now, almost 8 years. I've been doing it pretty much daily in production. Even when I do training, I still take contracting gigs to kind of keep my skills up, and I think that's pretty important. I loved Go so much that I actually started one of the first Go meetups in the world, Denver Gophers. So if you're in Denver and you've attended one of those Go meetups, that was actually because I had the bright idea of starting one of those. I won't go into the details of how long it took to get that off the ground, but it was a lot of work. Super glad I did it, and it just makes me so happy to see how wonderful that group has turned out, and how hard they keep working to keep that going, and what a great set of people that run that. I've delivered Go training workshops all over the world. I've been very fortunate to be invited to India and London and all that kind of stuff. So really, that's been great as well. Really like to go and do that. A little bit different with the pandemic, as you can imagine, as evidenced by me being virtual today. And I've been doing Go training solely and full time for over 3 years with my business partner, Mark Bates, as most of you know, at my company, our company, I should say, Gopher Guides. So that's a little bit of history. And again, normally I don't like to talk about that too much, but I think it's important because it's going to give a little bit of background on how we learned some of these things when I thought I knew Go. So this talk is actually made up examples that were created after a student in one of my workshops asked a question. And I should say mostly made up of examples. There's a couple examples that, certainly we worked off of. But as we worked through these examples, a student would ask a question and say, well, what happens if I do this? And the reality is that, as a Go developer, we tend to do things the Go way. But when a student's going to ask you a question that's counterintuitive to everything we do, it kind of catches you off guard. And so as a result, we actually don't know the answer because it's really not a Go idiomatic way. And so when that happens, we really have no choice but to live code it in class, and we all get to find out exactly what's going to happen. And that's kind of actually led to a lot of what moments, and certainly during training. All right, so let's get started. So one caveat here is we're not going to cover all of the what moments of Go. That would take days. And I don't mean to say that is degrading to Go at all. I'm just saying that with any language, especially Go, you're going to certainly find that things don't always act as they appear. So let's start off with something fairly basic, right? Let's start off with some numbers. And we're going to start with the type system, specifically the numbers types. And as many of you know, there are a lot of numeric types in Go. When we look at this, we see like the uint 8, the uint 16, so on and so forth. And there's a lot there. And this kind of gives you an idea of like what their different sizes are, to kind of give you an idea of the different ranges and maybe what you would use them for. I'm not going to go deep into this right now, but it is good for background information for this next piece I'm going to talk about. But in addition, Go also has what we call implementation-specific types, okay? So that's int or uint. Now, int is the one that we use quite often, right? You've probably seen that. But as you can imagine, between this set of numbers right here, the system-specific types, and this set of numbers right here, the implementation types, it leads to the question, especially in class with this wall of options, the first question I always get is, how do I know which one to use, right? That's the first question I normally get. Now, the answer is kind of like a self-fulfilling destiny, and it's a hard answer to give the students when they're first learning, but it's one of those things where when you need a very specific numeric type, you'll almost always know you need it because your code will demand it, or because of other code you're consuming, or in the unfortunate case that maybe you're loading a DLL from Windows or a C library. In those situations, you're kind of already walked down that path, and they've already told you it's going to be a uint32 or something like that. Sometimes you know because you're trying to pack a specific number type, those types of things. But fundamentally, you don't come to it and say, oh, I need an integer and go, oh, do I need a uint16 or uint32? If you don't already know that you need that, then you typically just want to use an int or the implementation specific types. So it's pretty safe to pick that. However, that's actually not the interesting part of numbers in Go. Just kind of leads into how much we have to think about with numbers. So let's do something like this. Let's go ahead and we're going to pick a uint32. And if we look at the following sample code, we're actually going to see that this is the max value. So I calculated this earlier, and the max value of a uint32 is this really big number right here. And so if I have this set of code, I set a variable, and I print it out, it will actually print this number, right? Pretty straightforward so far. So what happens if I just add 1 to the value? Now remember, the value we picked is already the max value that can be stored in a uint32. So the question here is it going to compile? Is it going to run? Is it going to panic? What does this do? Now, many languages, it's very obvious what it's going to do. But Go, it's not quite as obvious. In Go, if we add 1 to a max int 32, we actually get 0. So that's because in Go at runtime, instead of a panic, the value is going to do what we call wraparound. It's just going to basically go back around and start at the 0 value again. Now, as you can imagine, if this happens in production and you haven't coded for this, this is going to be a pretty hard bug to spot, right? This is not going to be a fun day for you trying to figure out what just happened. All right, so that's one of the gotchas you have to watch out for Go at runtime. All right, but what if we actually take and do it this way? What happens if we take and declare a max uint32? Here's the max value that we just had before, and now we want to add 1 to that value. All right, so this time it's not going to be at runtime. This time it's going to be at compile time, right? So this one back here happens at runtime because the compiler doesn't know necessarily what this variable is going to be at runtime. It's not going to go that deep into the code. But this time it's going to be at compile time. And so is it going to compile? Is it going to run? Is it going to wrap around, or is it going to panic? So what happens this time when we do the basic same operation, but it's a different point in time at which the compiler knows this number? So this time, we're actually going to get a compiler error. The code actually won't compile. And the reason for this is because the compiler can actually detect that the value is going to exceed the boundary of that uint32. So this is the difference, right? So if it's runtime, it's going to wrap around. And if it's compile time, it can actually determine the value of that number. Then it's going to throw an overflow, which is only a compile time error. So same operation, 2 different results depending on when you're doing it and what the compiler can determine. So again, like I just said, Go has that potential to both overflow a number as well as wraparound. And the overflow is just going to happen when you try to store a larger value than the data type was designed to store, and it happens at compile time. And that's only if the compiler can do the math right there on that line and say, oh, like this is going to be too big. That's not going to work out for you. Otherwise, if it's at runtime, it's going to be a wraparound. And wraparounds are something you really got to pay attention to in your code if that can happen. And you're going to want to make sure you write tests around them, because when they do happen, if they're unexpected, they're certainly going to be a very hard bug to track down. All right, so that's my little bit on some gotchas when it comes around Go. And this is actually the overflow I knew would happen. The wraparound, when I first started training Go, I actually did not realize that it was only at runtime. Like I knew wraparound would happen, I knew overflow would happen. I didn't actually know the difference of when they would happen. So that I actually learned on the job. All right, so now let's talk about strings a little bit. So most of you probably know that by default, Go actually does a good job of supporting UTF-8. But let's see how well you actually understand it. So let's take a really common example you've probably seen a lot. In fact, if you've ever done the tour for Go, you've probably seen this quite a bit. You've seen where we go ahead and we take a string, we throw some UTF-8 characters in there, and it goes ahead and shows you a couple different examples. In this example, all I'm going to do is I'm just going to print out the length of this string. Now, if I count these, right, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 characters here, right? So typically when I come to a new language, if I've got 9 characters and I print out the length of a string, what would I expect to print out, right? Now, I know all of you already know this isn't going to print 9 because I'm making such a big deal out of it, but normally it would print out 9 in most of the languages. In Go, however, we actually get the value of 13, not 9. Now, the reason for this is because runes in Go are special. And a rune is just an alias for an int32, and a rune can be made up of 1 to 3 int32 values. So there's kind of a lot to unpack right there, but kind of to boil that down, this right here can be 1, 2, or 3 int32 values, and this can be 1, 2, or 3 int32 values. That's what a rune is. Now, natively, Go handles this for us as long as we're using strings and using the UTF-8 package when necessary to do things. So it handles things very nicely out of the box. But if you're not aware of that, you might get some things where maybe you're saying, hey, if I'm expecting a string to be this length and you do a length of it and it's not, that's because it might have a special character in it, and that's going to create problems for you. So let's even go a little bit further with that same example right now. So in this case, we've got our hello world string again. And in most languages, when you come to them, you would think if I want to index through that, I would just do a for I colon equals 0 when it's less than length of the string, and then I++, and then just print out the index of that actual value, right? So in this case, I'm going to print out the index that I'm at and the actual value. Now again, this does not behave the way you would expect in Go. Because when I get down to the special characters, these are the runes, right? 7, 8, 9 is a rune, and 10, 11, 12 is a rune. But they still have their individual int32 values. So while I can certainly run through this and index through it this way, these are clearly not the characters that I have up here. And that is because I'm kind of breaking the rules a little bit by indexing through this string one value at a time. So how would I do this the right way? And how would I know to be able to index through this and range through this and loop properly? Well, I just gave you a little hint right there, right? I said range. That is because in Go, we have the range keyword. And this is the right way. Now, range is a little bit magical for us. It's actually going to take a look. It's going to know that this is a rune, and it's going to do the proper thing when it prints it out. More importantly, notice that it actually gives the proper index, right? So I actually get stuffed with the correct index at this point. So if I wanted to, I could index into A as well, but I would also need the length of this. So the correct way typically to range through a string in Go is just to go ahead and use the range keyword. That'll save you a lot of headache, okay? So again, a little bit of gotcha when it comes to strings and UTF-8s. So we can't use them like we do in normal languages or languages that we might be used to. We have to make sure we use the right operators on them, or we will get certainly some unintended results. All right. So on to my favorite part. Out of all of the training I do, and I do some pretty advanced stuff too, but out of all the stuff I do, this one right here has certainly been the biggest gotcha that I think everybody learns when I train it. And I think anybody who's doing Go for a while, you certainly have probably run into what I'm about to show you. But if you're somewhat new to Go, this is something that is a little bit infuriating. All right, so in Go, we have both arrays and slices. And most of us know that slices are just the go-to type for storing a list of data. Now, they're going to allow us for convenient manipulation of a list of items. And many of us also know, and we'll see who knows where this saying comes from, is that with great power comes great responsibility. All right, we'll see at the end of this talk if anybody knows where that comes from. I suspect some of you do. Specifically as it pertains to slices, or more specifically, subslices, which is really what I'm going to focus on next. So a subslice is when we just take a piece of a larger slice. So in this instance, we're just going to take the first 3 elements, of which you probably recognize as guitar players, right? So in this case, I've got this slice of names, right? John, Paul, George, and Ringo. And I'm just going to go ahead and I'm going to print out the names here, all right? So just to show you that it really is John, Paul, George, and Ringo. And then I'm going to take a subslice of names, right? So in this case, I'm using the short nomenclature here. I'm saying colon, which says start at the beginning of the slice, and get me 3 elements. Now, slicing in Go is also a little bit interesting when it comes to it. If you've ever wanted to know the actual syntax, it's whatever your starting index is, and then it's the starting index plus the length of items. So this usually gets people as well. It's not quite like how other languages work. So again, if you're getting into Go, slicing will take a little bit to get used to as well. All right, so then finally we print out guitars and we get John, Paul, and George. Now, just to show you that this really does indeed work, we'll go to the playground and we will run it. And this is our original slice names, which is John, Paul, George, Ringo. And then the sub-slice of guitars right here is John, Paul, George. All right, so far nothing too exciting. I think this one's pretty straightforward, but let's keep going. So now what happens, however, when we mutate the subslice? So I've got the same code I had before, right? I've got my slice of names, John, Paul, George, and Ringo. I'm going to print it off just to keep it in our minds here when we look at the results. And now I'm going to go ahead and take a subslice of guitars, which is going to be the first 3 elements again. I'm going to print that out just to keep that in our history. And now I'm going to loop through guitars, and I'm just going to uppercase all of the guitar values, right? So I'm going to uppercase whatever is in guitar. That's all I'm going to do here. And now I'm going to print out not guitars, I'm going to print out names, all right? And really, I should probably print out guitars too, just to show you, which I can do. But here's the gotcha, right? So what's going to be printed? So let's go ahead and run this code. And let's go ahead and just print out guitars here too at the end. Do that. All right, so I'm going to print out names and guitars. All right, so here we go. Let's see what happens. So we've got names, as we would expect. We've got guitars, as we would expect. But now, after we go through and we change guitars, right? Be really clear, I'm not changing names. Notice that the first 3 values of names is actually changed, right? So we changed guitars, which we would fully expect to have changed, but we also changed names. Now, I think when you first come to Go, this is very unexpected. Now, in Go's defense, and the authors of Go, this is clearly documented in Go, right? If you read Effective Go, if you read the language spec, this is clearly called out. In fact, I even read this in the spec. And the first time I encountered this in my code, I even went back to the spec and I reread the spec, and you know what? I didn't get it. To be quite frank, I didn't get it. I did not understand what it was saying. And so I was really actually quite frustrated at the time that this happened. And I thought, this is insane, right? Like, how is it that I'm modifying this variable here? It's a brand new variable, right? I just instantiated a brand new variable here. How is it that I'm actually still working on this value up here? I was actually quite indignant. And I saved myself a lot of embarrassment because I did write quite the scathing letter to the Go team at the time. And I was like, wow, like this is ridiculous and this needs to be documented and blah, 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 blah. And before I sent that ridiculous letter that I had created, I actually went back out and read the language spec one more time. And then I finally understood. Like, it finally clicked in my head what was going on. And I'm so glad I did not send that letter because I would look like such a fool and such a jerk. But anyway, it was a good exercise in my mind to kind of go through and get it straight. All right, so some of you are probably still saying, yeah, but why, right? Why did this happen? All right, well, let's think about this. So slices just wrap arrays, okay? And the thing that we have to understand is that just because a slice wraps array, that when we take a subslice of an array, that subslice doesn't create a new backing array. It doesn't actually create any more memory. So on one hand, that's really cool, right? Meaning that we're going to actually save a lot of memory. So if we took a large slice of large subslice of a big slice, we don't create more memory in Go, which is really cool. We're going to use that underlying array, but we're just going to point to a window of that array, the one that we sliced from. So anything that we change, we're actually going to change the array that we sliced from, the originating backing array, right? And when we think about a slice, it really has 3 values, right? It has a length, which is how many items are in it. It has a capacity, which is what is the size of that underlying array. And then it has a pointer to that underlying array. So that's really what we have, right? Length, capacity, and that underlying array that we're pointing to. And when we take that subslice, all we're doing is creating a new length and a new capacity, but we're really actually still pointing to that underlying array of the first slice that we got. That's the confusing part. But if we look back here, or I should say here, right, it's pretty clear what happened at that point, right? Like, we are still pointing at this piece, right? So when we took this slice right here, we just said point to these 3 elements. That's all we did. We didn't create a new underlying array. We just said point to these 3. So that's the key to understand when we do that. All right, so if that's not bad enough, let's keep walking this forward. All right, so now given the same code, what happens if we make a modification to the guitar slice by adding a new element? So let's walk through this code. So here we've got our names again, right? I'm going to print them out just to keep them in my history. I'm going to take the same subslice I did before. Now, this time, before I actually range through them and uppercase anything, I'm going to append a new value to guitars, right? I'm actually going to add a value called Fred. So at this point now, I've got John, Paul, George, and Fred in my guitars, okay? That's what I've got in guitars. I'm going to go through, I'm going to uppercase all of guitars, and once again, I'm just going to print out names. That's all I'm going to do. In fact, what I should do here is let's print them out both again. So let's grab this here. Go ahead and do this. Print it out. Now let's run this one. Now this one always blows my mind when I do this, right? So check this out. Guess what happened? When I appended to guitars, what did it do? It actually said, hey, do I have space in the underlying backing array that I'm pointing to add one more value? Well, guess what? It's pointing to this underlying array, right? And it says, yeah, I got 4 spaces in here, and I'm only using 3 of them right now. So if you want to append to me, no problem. I'm going to go ahead and write into that last value that I've already allocated. So in this case, not only did I change all the values when I'm uppercase them from guitars, when I actually added a value to guitars, I appended to it, I overwrote Ringo in names, right? So to make it even worse, if I start adding things to guitars, I'll overwrite additional memory in that originating backing array from that slice, right? Again, this is documented, and this is the way it's expected to work and go. But if you don't know this one will really throw you for a loop. All right. But you guessed it, we are not done yet. So let's take it even further. All right, so we kind of talked about this. So now what we're going to do, pop this open here. So I've got my names, right? I've got my guitars. Starting to get used to this pattern. This time I'm going to append 2 values to guitar, right? This is what I'm going to do this time. I'm going to take 2 values of guitar, and I'm going to arrange through them and uppercase them all. So now what happens, right? So now we don't have space, right? We don't have enough space to actually write one more value or 2 more values. We have enough for 1, but not 2 in names. So guitar is going to actually append 2 values. What's going to happen this time? Let's run it. Here, we have a whole different scenario. This time, the names array wasn't mutated or changed at all. Not one bit, right? It's completely pristine. It's the exact values it was when we started from. Yet guitar certainly has all the changes we made to it, right? We got John, Paul, George, Fred, and Wilma, and they're all uppercased. What in tarnation is going on here? How did this happen? Why is it one time we modify the names backing array and then another time we don't, right? This is pure insanity at this point. However, this is documented, and this is how it's supposed to work. So what actually happened here? This is because the underlying array for names only had a capacity for 4 values. And when we went to add 2 values to guitars, Go actually says, oh, there is not enough capacity in the underlying array that names is pointing to. So it creates a brand new underlying array of whatever size, actually size 8. I know this because I've done it so many times. It'll create a brand new array of size 8. It will copy the values from guitar, which will be John, Paul, and George at the time, right? Those first 3 that I sliced. Copy them into that new array, and then write in Fred and Wilma. So at that point, guitars is now referencing a brand new underlying array, and names is still referencing its underlying array. So when we made the slice, guitars was pointing to here. And as soon as we called append, guitar says, oh, I don't have enough space in that underlying array that I sliced from. I'm going to make a brand new one. And guitars now gets its own memory space at this point. And that's the only time that happens from when you slice, is if you exceed that underlying capacity of that array. All right, so is this confusing? Yes, it is. Super confusing, right? Craziness. And you really got to pay attention. All right. So now that we know the runtime is going to grow an underlying array for a slice when it hits a certain number, in this case 4, let's start with a slice that only has 3 values in it and see what happens. So at this point, I've got my slice of names. I got John, Paul, George. So I'm just starting with 3 names at this point, right? So names only has 3. I'm going to slice the whole thing at this point, right? I'm just going to say guitars equals names, the whole thing. And then I'm going to go ahead and just add Fred to it like I did before, right? Same thing I did before. I'm going to run through and do my strings.upper on guitars. Do we know what's going to happen this time, right? So it feels like at this point, I should be able to make this happen, right? It feels like at this point, the same thing's going to happen the first time. I'm going to go ahead. I'm going to actually change all the values and names to uppercase. I'm going to go ahead and actually just add a value of Fred Now, does Fred show up in names? Like, what's going to happen here, right? All kinds of questions at this point. A little bit different, but I suspect it's not what you think is going to happen. And why is that? Because I tricked you. So as we can see, the values of only guitar slice changed, right? So why did the original backing array of the name slice not change this time? Okay, that's a really good question. We know that it should have had space, right? It should have had a capacity of 4 because it only had 3 items in it, and that's kind of how the runtime works. What happened this time? Why did it magically create its own underlying array to add that extra value? Well, it's because I made the original one with a make statement and said it was only 3. So if I go ahead and use the make statement, Go is only going to create an underlying backing array of the size I tell it to, right? The actual size. And because of that, when at this point we went to append, it said, oh, names doesn't have enough space for the underlying backing array, and guitars is going to have to create its new one. All right, so this is me kind of tricking you, but I did this on purpose. I wanted you to see that we can't just assume that we know the breakpoints of a slice. In fact, it starts out at size 1, 2, 4, 8, 16, 32, 64. As you can imagine, you can kind of do the dance, right? You can do the math on that. Keep going up to some magical, actually large number where it just keeps then adding that much chunk space again. But fundamentally, I do this right here to show you a very important point. You can't assume that because you know the length of an actual slice, whether it will mutate the other one from subslicing and when it actually adds to it or not, based on the runtime mechanics, right? Because I can actually fool it a little bit by saying, well, I'm not going to start with the runtime making the decision. I'm going to make the decision. In this case, I did, right? So that's the other piece. All right, so that really begs the question when we're all done here, and it really says, when can I safely mutate a subslice? And this is I love this response. As with all programming questions, the answer is it depends, right? I always answer every programming question with, well, it depends. And I know that gets frustrating, but it's true. So there is one rule we can follow, is never modify a subslice if you need the original slice not to change, right? So if you don't want the original slice values to change and you've taken a subslice, don't mutate that subslice. Don't make any changes. Now, you could get clever. You could investigate the capacity and the length of both the original slice and the subslice before mutating the subslice. But this adds a lot of extra complexity to your code, which tends to lead to bugs. And you're also kind of fighting the runtime a little bit, right? Like you're kind of defeating the purpose. And what I tell people is that unless performance is truly an issue, then the best solution is just to make a full copy of that subslice, which will ensure that you don't modify the original. So in the event where you need to keep the original subslice pristine and don't want to change it, or the original slice, and the subslice you're going to mutate, then we need to make a full copy, right? So how do we make a full copy? Let's do that real quick. So here's an example where I'm going to make a full copy. I'm just going to go ahead and pop this open here. So we've got our names, right? Pretty straightforward. And this time I'm going to go ahead and I'm going to make a brand new slice here for guitars, right? I'm going to say, listen, make a slice that I'm going to hold the values. And then I just use the copy keyword. I say copy. I tell it I want you to copy into guitars, and then I take my subslice, okay? Now at this point, because I made this and I copied the values in, names has its own backing array, and guitars also has its own distinct backing array. They no longer share a pointer to the same underlying backing array. I purposely said don't do this, right? I took the extra step and said don't do that. And so now I can append to guitars all day long. I can uppercase guitars all day long. And as you guessed it, I do, in fact, not ever modify the original slice anymore because I took the subslice and I copied those values in there, right? Now, this is less performant, right? I'm going to create more garbage this way because I'm creating more allocations. But typically, this is going to make sure your code is kind of bulletproof, right? You're going to make sure that we don't have any bugs lurking out there. So that's super important. And it's super easy to read too. So that's the other thing. So you've got code clarity. So that's why I prefer this way. If you really need to mutate that subslice and don't want to mutate the original slice, then you have to make a copy. All right. But wait, you guessed it. Copy also has some behaviors you have to watch for. So given the following code, what will be the output? So again, this is really simple code. I've got my names here. I've created a new slice called guitars. I'm going to copy a slice of names into guitars. I'm going to print out guitars. So what happens this time? Let's go ahead and run this very simple example. Ta-da! We copied nothing at all, right? So this is the other thing you have to watch for when you're using the copy keyword. Copy will only copy as many values as you have space for, all right? So this is really tricky. So this is one that will catch you as well, right? So if we really wanted to make this work, really the way we should have done this is we should have said make string 3, right? If we do it this way and run it, now we get all the values you want. To really make it even more confusing, what if I make this 2, right? So I'm going to make it size 2. I'm going to copy 3 values. Is this even going to compile? What's going to happen here? This one I actually had to find out in class. I was like, well, why would you do this? It'd certainly be a bug, right? It'll run just fine, but guess what? It's only going to copy what it has space for. That's the only thing it's going to do, all right? Now, to make things even more confusing, what happens if I say length of 2 and capacity of 10, right? Now what happens if I do an actual copy at this point? Now I'm going to get, do this the other way. Let's do a size of 10, right? I'll do size of 6, 5, whatever. All right, we'll do it this way. All right, so you've got all these different things that are going to happen here. Now, what's even crazier at this point is you can do things like you can put a append in here. You can get that kind of mixed up a little bit as well. I've seen it where you do a copy and then you do an append and you do a make, get all these things mixed up, then you'll actually get padding in front of this as well. And I've got another example of that somewhere, but we won't go into that. I think at this point, I've probably thoroughly confused everyone, which is the point, right? The whole point of this is that when you're dealing with slices, you're dealing with subslices, and you're dealing with then copy, you've got to keep all of these things lined up. And if you don't keep all of these things lined up, you're going to have problems. Now, what I end up doing whenever I'm doing any of this stuff with slices, the very first thing I do is I write a test. And I find that I get this wrong almost every single time. If I don't write a test to really ensure that this is exactly the way I want this to work, I'm almost always going to get it wrong in Go. And that isn't because I think Go is complex. I think it's just because Go is a little bit different. And as being a developer of almost 20 years at this point, I'm still unlearning things from other languages, right? And that's why I always write the test. And if I write the test, I know that it's going to work and I don't have to worry about it anymore. And I also tell you that because I think a lot of times people look at Go developers that have been writing Go code for a long time like, oh, like they've got this and why am I struggling so hard with this? This is a struggle. This one you'll struggle with. And if you've got it down pat and you don't struggle, congratulations. That's fantastic. But I do think that most of us struggle with this. Even every day as experienced Go developers, we still come back and we make really silly mistakes because we forget the nuances of how Go and slices and the backing arrays really work. So I think that's really important to understand, and that you shouldn't feel like you're not doing well like other people are doing because they've got this code written. Most people struggle with this. They really do. So don't worry about that. All right, so that was the make space example. It shows you how this works properly. All right, so in summary, okay, I went through quite a few things here. So Go definitely has some unexpected outcomes compared to traditional languages, all right? Understanding these outcomes are really going to help ensure that you have bug-free code. And I know I kind of showed some of the ugly side of Go today, but I still love Go. I would still rather write code in Go than any other single language out there. Yes, I drank the Kool-Aid. I don't know what it is. I can't say enough good things about Go, the community, the Go team, everything. Like, I love Go, and as long as I am still a developer, I'm probably going to want to keep writing Go. Maybe someday there'll be another language that comes along that makes me as in love with coding as Go does. But I've been doing Go for 8 years, and I'm actually more in love with it now than I was when I started, which is really saying a lot. So don't take the wrong thing away from this. I know I showed you kind of some crazy stuff in Go, and there's definitely been some table flipping moments for me with Go as well, where you learn some of the stuff, you're like, what just happened? And especially that sub-slicing one. The first time that got me, that was infuriating. But once you learn it, you get past it, and I still love Go. So don't take the wrong message away from this. I definitely love Go. Obviously, Corey Lanu at Go for Guides, we do Go training. If you need any Go training, certainly hit us up. We'd love to help you out. And I don't know if we have time for questions or not. I know this is pre-recorded, so I will let the moderators of the show decide if we have questions, but I will be here live when this goes, and I would love to answer questions. So thanks, everybody, for being here. Hopefully, I've been chatting with you this entire time and answering any crazy questions. And as always, feel free to reach out to me on Twitter. I'm on Go for Slack. I love to talk about this stuff. I love being part of the community, so don't hesitate to hit me up. Again, thanks, everybody. Super glad I could be here. I hope you enjoyed the talk.